Well, hello everybody. I'm just going to go over how to get started on the Boyle's Law problems. So I'm not going to actually do any calculations here, but we're just going to talk through how to get these set up. Now, Boyle's Law is a law that talks about how your pressure and volume are related to each other. And in our lab that we started off the unit with, we made a graph in class. We had pressure down here, and then we had volume labeled over here. And what we had was, so we had, when we had very low, I think we had, our pressure was 0, basically no textbooks. We had a very large volume of gas. We were up something like this. Then as we added more books, and which translated to more pressure, we got less volume. The volume got smaller. The higher the pressure, it squeezed that little drop. And so what we started to have happen was we started to get a graph that looks something like this. So what this is showing is that as the pressure is getting higher, the volume is getting smaller. So in this one, pressure is increasing, but our volume is getting smaller. And when we have a relationship like that, we say that it's inversely related, that they vary inversely with each other. So first problem here, now here's a methodology I'd like you to follow. A sample of oxygen occupies this volume, so we'll call this volume 1, our starting or initial volume, and the pressure is at 740 torr, so we'll call this pressure 1. What volume? Okay, well, we're looking for volume, so it must be we're looking for volume 2. Will it occupy at 800 torr pressure? So this is going to be pressure 2. Now, we're both given pressures in torr, so we don't have to do any conversions. Now we're going from a lower pressure of 740 to a higher pressure of 800. So what's happening is the pressure is increasing, so we should expect the volume to go down. We should expect our answer should be less than this. So when we set these up, we're going to do pressure 1 times volume 1 equals the new pressure times the new volume. Let me zoom in so you can see better. Pardon me. So we've got to solve for volume 2. So we need to divide both sides of the equation by pressure 2. We want to get pressure 2 away from here. So now we're going to take the starting pressure, 700, this is 740 torr, and we're going to multiply that by the volume, the starting volume, which was 250 milliliters. And then we're going to divide it by the new pressure, which is 800 torr. You need to make sure to always put your units. Now the torrs can cancel out, and our answer is going to be in milliliters, which makes sense because we're looking for volume 2. So now in your calculators, you need to multiply 740 times 250 and divide by 800. But if I just kind of ignore the volume, look at there. Our ratio is 740 to 800. This is less than 1. This fraction is going to make this 250 less than 1. So we should get an answer that's smaller than 250. Because the pressure's going up, the volume should be going down. Now let's see. Let's go to number 2. Now we're just gonna kind of set this one up. Okay, we got carbon dioxide occupies this volume. We're in liters this time, and at this pressure. This is kilopascals. You might see this on a bicycle pump or a car pump. A lot of times they have, for metrics, they use kilopascals. We tend to use PSI. Now what pressure? Okay, so we're looking for pressure, so that's going to be the new pressure because we already got this labeled pressure 1, so we're looking to find pressure 2. What pressure would it exert if the volume was decreased to 2 liters? So we're decreasing, this is the new volume. Now our volume is getting smaller, so since volume and pressure are inversely related, if this is getting smaller, we should expect the pressure should start to get bigger. So let's set this up. Our base equation, P1 V1 equals P2 times V2. This time we're looking for pressure 2. So now we want to divide both sides of the equation by V2, or the new volume. These will cancel out. So this time, okay, pressure 1 times volume 1 divided by 2. So there you go. Let's see, number 3. Read through this. We have a 2-liter container, has this pressure, so we'll just call this volume 1 and pressure 1. What volume? Okay, we're looking for volume, so it must be volume 2. Would be necessary to decrease the pressure to 1 atmosphere. This is pressure 2. So let's see, what volume? So we're looking for volume 2 again. It's going to be the same equation we solved for over there. Number 4, we got some ammonia gas. And it has a starting volume, volume 1, and a pressure of 720 millimeters of mercury. So that's going to be pressure 1. Now, a millimeter of mercury is the same thing as a torr, which we talked about in our notes. So we could also say this is the same as torr. Okay, they're exact same quantity to the unit. So I'm just going to put torr over this because then it just makes it easier. We're kind of used to that one. What volume? Okay, we're looking for volume 2 again. Okay, so we can use our equation from number 1. Will it occupy its standard pressure? Standard pressure. In our notes, we talked about what standard pressure was. We said standard pressure is 1 atmosphere, which is the same as 760 torr, or 101.3 kilopascals. Since this problem is in millimeters of mercury, which is the same thing as a torr, let's say standard pressure is 760 torr, which is the same thing as a millimeter of mercury. Okay, so on this one, so set it up as you did number 1, multiply them out. Number 5, we've got, this is our volume 1 of neon. Okay, we have some neon gas. Its pressure changed from this to that. So pressure 1 to pressure 2. We're using kilopascals here. They're both the same, so we don't have to worry about that. What's the new volume? Oh my goodness. Once again, we're looking for volume 2. You're going to set it up just like we did the first problem, and then you're just going to multiply it by the appropriate values in there. Number 6, let's see if there's anything troublesome here. We've got, this is pressure number 1, 1.5 atmospheres, and the pressure was decreased to half an atmosphere, so that's pressure 2, producing a new volume. Okay, now they say the new volume, so if it's a new volume, that's going to be volume 2. What was the original volume? So now we're looking for volume 1. Pressure 1 times volume 1 will equal pressure 2 times volume 2. Start with the base equation. We are looking for volume 1 this time, so we need to divide both sides of the equation, that's right, by P1. So now you're going to have your pressure 2 times volume 2 divided by pressure 1. So just make sure you get those substituted in correctly. Number 7, chlorine gas occupies this volume, that'll be volume 1, at this pressure. Okay, that's pressure 1. What volume? Okay, oh, once again we're looking for volume 2. Will it occupy at 1 atmosphere? Uh-oh, now we got 1 atmosphere. This is in torr. Well, we got to either change this one to atmosphere or this one to torr. And it's going to be way easier to change this because 1 atmosphere is how many torr? 760 torr. So let's just say here, okay, that's 760 torr, and that's going to be pressure 2. And so we're just looking for volume 2. Set it up just like that, pressure 1 V1 over pressure 2. And lastly, number 8, this one's slightly tricky. Fluorine gas has this pressure. Okay, when the pressure is changed to this one, so this will be pressure 1, this will be pressure 2. Now they're in different units, so we're going to have to convert one of those in a moment. Let's see, when its pressure is changed to this, its volume is 250. So that means, since this is pressure 2, its volume, this is volume 2. What's the original volume? Okay, we're looking for volume 1. We solved for volume 1 and see which one was it over here. Oh, I forgot to cross those off. Yeah, so volume 1 right there. But we got to be careful. We've got to either change this to atmosphere or this one to torr. So you know what? Let's see. I think I'm just gonna change this one to torr. So let's come over here. We have 900 torr. Okay, over 1. This is just a conversion factor. And let's see, we want to get rid of the torr, so we say there's 760 torr. This is just from the notes. And we want to change it to atmosphere. 760 torr is 1 atmosphere. So now, 900 divided by 760, well, I don't have the number. You can do that. But that's the number. Whatever number you get here, that's what you're going to use You convert that in there. We're looking for volume 1. Volume 1 we said up here was pressure 2 times volume 2 over pressure 1. So just do this conversion. Then your answer here becomes pressure 1 down on the bottom. And then you got your pressure 2 and your volume 2. So there you go. Enough. I'm done.